A Ferris wheel has a radius of 22 meters. It rotates once every 36 seconds. Passengers get on at the minimum point 1 meters above the ground. So the data that's given to us so far is that the distance from the ground to the bottom of the Ferris wheel is 1 meters. Alright, the radius is 22 meters, so that means this distance right here from the center all the way to the top, right, that would be 22 meters, the radius. And this wheel is going to rotate once every 36 seconds. So when I'm setting up my graph, I'm going to set up time as an independent variable at the bottom here. So time. And time is being measured in seconds. And we're looking at an equation that describes the height of a passenger as a function of time. So we're comparing the variables time and the height of the function. In meters. So I'm going to set up my scale factor here. So 0. It's going to take 36 seconds for one full cycle. So that means 36 seconds is going to be one full cycle. I'll draw two cycles just to kind of get an idea of what's happening with the graph. So 36 and then 72. Because sine and cosine functions, right, you're looking at their points at every quarter, right? We start off at 0, 45, 90. We start off at 0, 90, 180, 270, 360. We're looking at what's happening to them over 4 quarters. I'm going to divvy up the 36 seconds into 4 equal parts. Okay, similarly 36 to 72 into 4 equal parts. Now, as far as the height is concerned, one of the key things that we need whenever working with sine and cosine graphs is you need to know where the midpoint is going to lie, where the center is going to be. You'll notice that our data make sure that the center is not going to be at the level 0, 0. The center of our graph is actually going to be elevated a bit from 0, 0. And it's going to be, the center of the graph is basically going to be where the center of that Ferris wheel is. So we're actually going to have a midline at the same level where the center of that Ferris wheel is. Okay, I'm also going to label my y-axis over here. I don't really need all the points. I'm just going to pick some specific points strategically based on the data presented to be by the graph. I know the minimum point that I'm going to have is going to be 1 meter. So my Ferris wheel is 1 meter high. So the lowest height that the person can be at on this Ferris wheel is going to be 1 meters when they're just getting onto the Ferris wheel. Right? So this will be 1 meters. What is the maximum height this person can reach once they're on the Ferris wheel? Notice the radius is 22 meters. The radius is the distance from the center to the edge of the circle. So that means the center to the top is 22. The center to the bottom is also 22. Which means from the ground all the way to the top is how far apart? 40. 45. We're getting there. 45 meters. Okay, 1 meter above the ground where the person gets on, and then 22 meters for the radius of the center, 22 meters for the radius from the center to the top. Right? So altogether, the height of the person, the maximum possible height, is going to be 45 meters. What is going to be the midline? The center. 23 meters above the ground is going to be the center. And really those are the only key points that I need, because anytime you're working with a sinusoidal function, you're interested in the maximum, minimum, and the midline. 3 vertical values. And you're interested in every quarter of a cycle to see what the graph is doing. Okay, now that I've got that set up, I'm going to go ahead and start drawing my function. As the person gets on the Ferris wheel at the bottom and they start rotating themselves, right, this person is going to start rotating from here. Their height is going to start increasing. They're starting off at a height of 1 meter. The height's going to go up, 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 up. The height's going to reach 23 meters above the ground. Then it's going to go all the way up. It's going to reach a height of 45 meters above the ground. And then they're going to start coming back down again. Slowly the height's coming down to 23 again, all the way around, down to 1 again. So when the person starts, the person's going to start at a height of 1 meter. When a full cycle ends, the person's going to be back down to 1 meter again, above the ground. Agreed? Right. Midway through this person's rotation, right, when the person is fully halfway done the rotation, they're going to be at the top of the Ferris wheel. So halfway through that rotation, they're going to be at the maximum point of 45 meters. Where are they going to be a quarter of the way through the rotation? If they're only a quarter way up the rotation, where are they going to be? At the midline, at the center of the Ferris wheel. Right? So quarter of the way at 9 seconds, they're going to be at the midline. Similarly, on the way down, 3/4 of the way into the rotation, they're going to hit the midline again. And if you connect these points using a smooth curve, because the height is going to be increasing as a smooth curve, you'll actually get a sinusoidal function. This is what you'll get. As they go around the Ferris wheel, the height is increasing slowly. They hit a midline. They're going to get to the top. Once they get to the top, their height is going to start decreasing again. Past the midline, back down to 1 meter again. Right, so the height of that person is going to behave like a sinusoidal function. Similarly, in the next cycle, once they reach down again, they're going to start going back up again. They're starting at 1 meters. A full cycle later, they're going to be back down to a height of 1 meters. In between that, they're going to be at the maximum. A quarter of the way, they're going to be at the midline. 3/4 of the way, they're going to be at the midline. We're getting this graph because this person started at the bottom. Would you get the exact same graph if I told you the person's getting off or getting onto the Ferris wheel at the midline? Say there is an elevator that takes them to the midway point of the Ferris wheel and they get on the Ferris wheel at the midway point. Would you generate the exact same graph? Thank you.
You're welcome.
Yes or no? Are you going to get the exact same graph then? No, what would change? Your starting point, right? Your height at 0 seconds is not going to be the minimum point. It's going to be the midline. You're going to start off your graph at the midline. It would be the same as you taking this graph and shifting it to the left by 9 seconds. Right? That's the graph that you would end up getting. Instead of starting at 1 meter, you'd be starting at the midline, and so on and so forth. But that's the graph we're working with. So now we're going to use the information generated by this graph to try and help us write the equation. If you want to write the equation of this problem, we need 4 things that we discussed yesterday. What do we need? We need 4 parameters. A, B, C, and D. What does A represent? Amplitude. B represents 2 pi over the period because the sine or cosine function. C represents phase shift and D represents vertical displacement. I'll give you a few minutes to try and gather that information, those 4 key points from what we've drawn so far, and see if we can come up with an equation of height as a function of time. Let you write that up. Okay, let's see what information we've got so far. Can we determine the amplitude, A value? What does the A value end up being? What did you get for the A value? 22, right? The same as the radius. Or if you have forgotten how to just look at the graph and come up with that, you can use the formula max minus min divided by 2. Max is 45, min is 1, divided by 2 is going to give you 22. We need the B value. B value is going to be 2 pi divided by the period. So 2 pi divided by, what is the period of this function? The period of this function is 36 seconds. It takes 36 seconds to complete one rotation. So from here to here, that's the period. So the B value is going to be 2 pi divided by 36. So that means the B value is going to end up being pi over 18. And again, some of the examples that we did yesterday, the B value was a whole number. It doesn't have to be a whole number, right? It can be just a ratio. If the graph is in fractions of pi, and the B value is going to be a whole number. If the graph is in fractions of whole numbers, the B value is going to be in fractions of pi, right? Vice versa. C is the last thing we'll tackle because the phase shift is going to determine what kind of equation we're writing. Next thing we'll do is D value, vertical displacement. What is the vertical displacement? 23. It's 1 unit plus the 22. The midline is at 23 meters. And you can also use a set of formulae to figure out the A, B, and the D. And these are the formulae for A and the D. A is basically max minus min divided by 2. You can do the amplitude that way. The vertical displacement is max plus the min divided by 2. The center point is basically the average of the maximum and the minimum. If you want to find the center of something, you take the highest point, the lowest point, you find the average. Average represents the midway through. Right, so I'm just taking the average of max and the min, and I get the midline. So I can use the formulae, or I can just look at the graph, try and figure those out. The C value is going to determine what kind of equation I have. So I'll take 4 different choices for C. So let me see. Can you give me one C value and tell me what function that's going to correspond to? Let's say the C value is 0. There's no phase shift. What kind of function would you be looking at then? Sorry? Cosine? Be a little bit more specific. It's not going to be a cosine function. It's going to be a negative cosine function. Notice the cosine starts at the maximum, goes all the way down. If the phase shift is 0, you're starting over here, right? You're starting at the bottom, going all the way up. So that means you're looking at a negative cosine. So the phase shift is 0, you're looking at negative cosine function. What if your phase shift was, or the function's phase shift was 9 units? What kind of a function would you be looking at then? If we started our function 9 units in? Sine function. Positive sine of x. Right? Positive sine of x. Here we got negative cosine of x. Another value. Can someone give me one more value for a starting point? 18. We could also start off at c equals 18. What would the graph be if we started at c equals 18? Positive cosine function. A positive cosine function starts at the top. And then one final one, c equals 27. What kind of function would start at c equals 27? Negative sign. You're starting off at the midline, but you're going in the opposite direction. So it's negative sign. So your phase shift is going to determine what kind of an equation you're going to write. So let's pick one, or we can write all 4 of them. So let's start off with the first one. Say we have a phase shift of 0. So one of the equations we'll get as a result is height as a function of time equals negative 22